So here is chapter 20. You can follow along with the notes pages or just listen and watch as far as things go. So a lot of new functional groups here in this chapter, but they all follow the same sort of pattern that allows us to look at them similarly, right? So from a carboxylic acid, which we've seen before, to an anhydride, which is relatively new, or an acyl halide, which is new as well. What they all have in common is the polar pi bond part, right? So it's going to react similar to what the reactions have been so far. A carbon with a partial positive, an oxygen with a partial negative. We can break that double bond. That still happens in this chapter, in this mechanism. But now instead of like an aldehyde or a ketone just having another carbon there or hydrogen or something that doesn't get removed that easily, all these functional groups have something that's either more or less a better leaving group, right? So think chlorine here, that's a decent leaving group. OH as part of this carboxylic acid, it's not an alcohol anymore, but if we were going to try and remove this, that should be difficult to do, right? So that defines a lot of the chemistry of this chapter. The overall mechanism in chapter 20 involves that leaving group, so right, from a generic, essentially what we're doing is taking a nucleophile, just like before, breaking that pi bond, adding something new, right? But this is the part where it gets different. So instead of then, okay, so now I'm stuck here, let's add some acid or water or some sort of solvent to turn that into an alcohol. What can happen in these reactions, since you have a decent leaving group, is double bond reforms, leaving group breaks off. Oops, not negative charge anymore. Right? So this is a substitution reaction then. So a lot of what came into play with substitutions comes into play here as well. So, the reaction depends on how good your nucleophile is, right? The reaction depends on how stable the leaving group is in the product, right? So these are important factors in these reactions that are going to come into play and make things work, right? So through all of these different reactions, different mechanisms that we've got, right? Again, that reactivity ends up being really important. So if you have an acyl halide as your functional group, then if you substitute that, you're going to get chlorine as the leaving group, right? And that's a pretty good leaving group, right? If you have an anhydride and do a substitution, you're going to lose this piece here, right? That's going to be your leaving group. Hey, look, that's resonance stabilized leaving group. Hey, we know this stuff, right? A larger atom, something with more resonance stabilization, right? A electronegative oxygen atom, but it's small. It's going to be pretty reactive, not a very good leaving group. Nitrogen is less electronegative, even a worse leaving group, right? So our reactivity scale goes from acyl halide down to amide being the least reactive, a lot of it based on those leaving groups, right? That leaving group stability really matters to make these reactions work or not. So